amplitude only changing. If there is no energy loss, amplitude does not change. That means energy remains constant. But in reality, what happened? Amplitude keep decreasing. All other factors, m and omega, remain same. Okay, that's called damped. Such cases, see, m will not change, omega will change, but amplitude keep changing. Amplitude keep decreasing finally because energy loss is taking place. So that case, we have to show graph like this. Okay, amplitude, see, first it went to 1 centimeter, then opposite 1 centimeter, then 0.9, 0.9. It should come down. Okay. 1 minute. Like this, see, amplitude decreasing, decreasing, it goes like this. See? Understood? Like that, keep reducing amplitude. Any doubt?
No, sir.
So this is the idea of damped. Is it clear now?
Yes, sir.
So forced vibration, free vibration, I told you that frequency will not change. F is equal to 1 by 2. Each system has its own values. I gave you some example. Simple pendulum 1 by 2 per root of L by G. Mass of vertical oscillation of spring, same answer. But for oscillation horizontal spring, root of M by K. Then we have seen this is natural vibration. That will not change until that factors in the formula does change. Forced vibration means some other body forcing this to vibrate. Okay, so this is a forced vibration. And then resonance, I told you, when these two are equal, vibration will be higher amplitude. I was telling about this one, microwave oven. In microwave oven, actually what's happening, microwaves frequency around 10 to the power 15 of 10 to the power 11 hertz. 10 to the power 11 times these waves are vibrating in microwave oven. Ten to 10 to the power 11 times microwaves, it's vibrating. Okay, so if you take water, roll number 33, roll number 33, just so water, if you're taking natural frequency of water, water molecules are vibrating naturally with the same 10 to the power 11 hertz frequency. So if this water, if you're exposing to this microwaves, see same vibrations. So that makes water molecule vibrate very vigorous. So kinetic energy of the molecule will increase and automatically its energy also will increase. That's why temperature is increasing. I told you, kinetic energy of the molecule directly giving temperature. So in microwave oven, we can mainly cook the water content food materials only. Dry foods and all you cannot keep. If you're keeping egg, boiled egg, you just try, but take cautions. Just warm, heat in the this one boiled egg. Okay, just heat in the this one. After cooling, just heat little more in the cook this one and use a spoon. Just touch it. It will explode like a bomb. You see that. But the problem is that inside content, if it fall, it will burn. So this all you must take care in the pressure. This one micro oven, dry foods and all you cannot keep. Always we should keep more water content. Okay, I'm not going much detail about it. So this is also resonance. Then I told you Britishers while marching, bridge used to break. That's also resonance. I told you these examples. Okay, right. More examples you can watch in video, or if possible, I will send some video. So that's over. Next we are starting with. So that part, free vibrations, forced vibrations, resonance, damped oscillation, undamped oscillation. Copy notes from your I sent you PDF. Next,
33
waves.
present.
Fine,
Tanzil
wave.
Muhammad.
Waves. Waves are a kind of disturbance, right?
Tanzil.
Next heading. Waves. Write down. Waves are a kind of disturbance which travel through a material medium. Waves are a kind of disturbance which travels through a material medium, having the property
Travel?
of
Sorry, sir. Which travel?
waves are a kind of disturbance which travels through a material medium. Travels through a material medium, having the properties of elasticity, having the properties of elasticity and inertia, elasticity and inertia on account of repeated periodic motion, repeated periodic vibration of the medium.
Sir, on account of
Huh?
after on account of
Waves are a kind of disturbance which travels through a material medium having the properties of elasticity, having the properties of elasticity
yes, sir.
and inertia on account of repeated periodic motion, repeated periodic motion about their mean position, and the disturbance being handed from one particle to another, without any net transportation of the medium, without any net transportation of the medium. That means we know if you just take a spring like this, okay, just a spring, 10th standard you must have studied it. Hit here with a stick, then you know this region of the spring will come down like this, isn't it? It will come down, but next region will go up, next region will come down, like this it will go, right?
Yes, sir.
Isn't it? So this is going down, this is going up, this is going down, this is going up. So this disturbance reached the other end. So this medium particle, it was in this line, actually it was in this straight line, but after disturbance this keep moving up and down, this particle moving up and down, is it continuously moving up and down? So every particle making periodic motion, repeated periodic motion, but wave keep traveling. Okay, similarly, suppose a spring we are keeping like this and compressing here, this region compressing and releasing it. So you can see it keep vibrating like this, and energy goes from this end to this end. So here also medium particle are making to and fro motion and energy get transmitted. But spring does not travel by its own. It's only making vibration. But through this medium, energy keep traveling. See, when I'm speaking, sound energy reaching your ear or a person standing there, but air doesn't flow. When my vocal cord vibrating, air in contact with the vocal cord compress. When it is expanding, that expanded air colliding with the next segment, that compress. That means my sound energy reaches that compressed segment. Again, while it's expanding, next segment you can see compressing. So this energy keep transferring through compression. When it hit on our eardrum vibrate, we get sensation of hearing. So here, through the medium does not travel. See, when I'm speaking, the whole room air is not moving. The reason, only energy is traveling through that. Medium particle only vibrate and carry this energy along with it. For this, medium particle should have two properties. First thing, they should make a simple harmonic motion. They should go forward, come back, receive energy, again keep transferring, it should keep on vibrating like this. Just like in a line, suppose you want to transmit something to you, you want to send something, distribute something, you will take it, give to other person, take it and give to other person. So it is simple harmonic motion, same like that. And it should have a property of inertia. Inertia means vibrating to one side. When it come back to its original state, it should not stop. Due to inertia, it will go to other side, receiving the energy. It should not stop. It should go to other side. So it should have a property of inertia as well as elasticity. Elasticity means after vibration, it should not stay there. It should come back to its original place. So it's very interesting now. Just listen now. A kind of disturbance which travel through a media having the property of elasticity and inertia. Otherwise, wave cannot travel. And on account of repeated periodic motion of the medium about their main position. Disturbance being handed from one particle to other particle in the media, but the medium particle does not have a net transportation. Net transportation means to and fro they transport, but resultant transportation is zero. Plus displacement minus displacement, zero. That with respect to mean position, it doesn't go. Medium does not travel its own. This is the idea of wave. Is it clear?
Yes, sir.
Now we are
Yes,
going.
sir.
Two types of waves are mechanical waves and electromagnetic waves. Mechanical waves and electromagnetic waves. Electromagnetic waves. This year we are going to mainly focus on mechanical waves. Next year we have full chapter of electromagnetic waves. First let us study mechanical waves.
Okay, sir.
There are two types of mechanical waves. Two types of mechanical waves. Transverse wave and transverse wave and longitudinal wave. And longitudinal wave. Transverse wave and longitudinal wave. First, I'll tell you how the transverse wave comes. Okay, look here, I'll tell you a very interesting example. This is like an art integration, usually school time students can do. Look here, suppose here around one class students are standing here. Just example, okay, they are medium particle, think like that. You're all molecule, think like that. So first person standing here, second, okay, first, second, third, fourth, like that. All students are standing in a line like this. Now medium particle not vibrating. Clear? Here, think these are all particles of the media, that which I marked. Here I am placing a boundary here. This is the maximum displacement these students can walk. That's called amplitude, think like that. Okay, just I'm giving an example. Okay, this is the maximum boundary this particle can travel, then it should come back. Then it should go to same side here, it should come back. Right? Now look. First, this boy, 10-degree phase it moved. Think, how much? 10 degree. I told you 10, 20, 30, 40, 50. This will be 90. This time is t by 4. While this is coming back, we can call him t by 2. When he reached here, we can say t by 3, t by 4. Now he reached back, it is t. This is one complete oscillation now. Okay, this time what's happening to another? All are connected. Think all these are connected with a string from one person to other person.
Yes.
So string connected. Think like that. So they're all medium connected. Now you see, this boy went to the 10-degree phase. Now all are in the same line, 0-degree phase. Think when this boy reached 20 degree, second boy came to 10. You understood? Same speed.
Yes, sir.
Now first one reached 30 degree, second came to 20, first one came to 10. When this reached 90 degree, second one is 80, next one is 70, next one is 60, then 50, 40, like that. See, this is 0. Think like that. Now t by 4 time, when the first particle reached here, this will be the nature, right? Nobody will be on this line. Nobody will be on this black line. This line will come like this. And from here, all are in the line. So now you see, from here, one wave, one wave This is called 1 lambda. Length of one wave is called 1 lambda. Half of the wavelength is known as lambda by 2. This much if you are taking 3 by 4 lambda. This is lambda by 4. 1/4. Half 3 by 4 full lambda. This is the meaning of 1 lambda. That means first particle, when completing the oscillation T by 4, the energy reached up to here, isn't it?
Yes, sir.
Did you understand?
Yes, sir.
Yes, sir.
Think this is a string and one person
Yes,
take the
sir.
first one. So string will be like this now. Because all are connected. Think. So first one 90 degree, second one 80 degree. See, there is a constant phase difference. Phase keep decreasing. This is 0 phase. Now it's not vibrating. Now wave will be this much wave, this much part is formed. Wave will be this shape. This is T by 4 time. Now what happens? Here he started coming back. He comes to 100. He came back 100. When he comes to 100, okay, this will be the shape. When this boy come to 100, next person which was 80, he will reach 90. When this boy come to 120, he will come to down. Okay, same line only. They should not change their line. He will come to 120. This come to 110. Now this particle 100, next will be 90. When he is reaching 180, that means T by 2 he completed now. Now next particle just behind him. He is here. Next particle. That means 170. Okay. Next particle 160. Like that, if you take, you see, who was at 0 will reach 90. That means 0 will reach 90. Here 100 like that. This side will be 80 like that. So graph will be now like this time. That means this much is formed now. When this is completing T by 2, next particle, that means this is completing 180, next particle 170, next 160, 150, then 140, this is 90, this is 80, 70, 60, 40, like that. This much reached. Now first particle completed vibration T by 2. Now this particle reaching here. So just behind he will be there. 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 But now this will be the situation. I'll show you. This will be the situation now. See now it will be like this. That means first particle reached 270. The person here 260, 250, 240, 230 like that. He is now reached up here 180. This is 170, 160. See, this particle reached 90. This boy again 0. Clear? Now this is reaching here. Imagine. See, now one complete wave is formed. This one reached here. 360 is completed. Now wave will be like this. That means he completed 360. Next person see 350. Then 340, 330. This reached 270. This reached how much? 260, 250. This is 180. See, 170 like that. This is 90. This is 0. Now one wave formed. Is it clear?
Yes, sir.
So just think, students are standing in a line. First person moving, second person just behind. When he is going little ahead, he is just ahead. Like that, one after another, you are walking this one. So first person when completing one complete oscillation, you can see in this one line will form. One wave like this will form. Second time when he is completing one oscillation like this, one more wave would be formed in that. Is it clear?
Yes, sir.
That time first boy completed 2 pi plus 2 pi, 4 pi. Now this boy is just completing 1 pi. Like that. So in a wave if you are taking, see, in a wave if you are taking, see, when this is completing one vibration, wave will reach up to here. When he is completing 2 vibration, wave will reach here. When he is completing 3 vibration, wave will reach here. That's what we are saying 2 pi. This is 2 pi phase. 2 pi, 4 pi, 6 pi. It goes like that. Now, only one wave if you consider, look here, one wave when we consider, he completed 360 phase, but this is 0. It did not start. But phase difference if you are taking, see, he completed 360. This man completed 270. This is completed 180. This is completed 90. This is 0. So phase difference if you're marking 360, this is same place 0. Now 90-degree phase difference, 180-degree phase difference, 270-degree phase difference, 360-degree phase difference. Phase and phase difference are reversed, isn't it?
Yes, sir.
So this is the way we are marking it. So 2 pi when the wave travel, this is lambda meter, it will go horizontal. So 2 lambda meter when travel, phase difference, this is 360, this is 0. So difference is 360, 2 pi. So 1 meter travel, 2 pi by lambda phase. X meter if it travel, phase will be 2 pi by lambda into x. There is a phase difference. So we can calculate, say for example, it is 8 meter wave, 8 meter. So we can say this is 8, this is 6, this is 4, this is 2, this is 0. I'm dividing lambda, 3 lambda by 4, lambda by 2, lambda by 4. Now look, you want 2 meter, 90-degree phase difference, we know, substitute here. Phi is equal to 2 into pi 180, lambda 8 meter, this is 2. This is 4, this is 2, this will be 90 degrees, 90 degree, pi by 2. If you substitute here 4, you will get 180 degree. If you substitute here 6, you will get 270. If you substitute 8, you will get 360. So if you want here, that means 1 meter, substitute here 1 meter, you will get 45. That means any point when you travel here, that point which displacement it made, or that particle from mean position, which one it made, that you can calculate here. 2 pi by lambda, just x from here, which distance you reached here, how much this particle reached. If you're reaching here, how much this particle reached. Like that you can find out vibration state from mean position. Is it clear?
Yes, sir.
So here every particle are actually making to and fro motion along the line. But effectively you can see wave is traveling here. And I will send some videos, you just see that. Okay? Or particle is moving only to and fro, but this disturbance keep traveling like this. This is the example I told you. Think of this way. Suppose here I told you again, there are students standing in this lines like this. When first person, okay, first person, this is the maximum distance it can go. Once you understand this concept, then easily it will go. Okay, I told you again, when this first person reach here, okay, when he is reaching here, t by 4 time. This time wave reaching like this. Clear? When he is coming back, shape of the wave will be like this. This time first boy came back, second boy came up to here, went up here and came back, third boy came back here, fourth boy here, fifth one reached here, sixth one reached here, like that. Think one after another they are traveling without break. Now this is t by 2 over. When he is coming here, I told you again, wave will be like this. It will be like this. That means this boy who started here now reached here, 270. Second boy, he went up to, he reached up to here. Third boy reached up to here. Fourth reached here. This boy 180 degree completed. This boy now reaching here only. This boy did not start this motion. So we can see 0 place. So when this is reaching the original place, then wave will be still moved. See, wave will be still moved like this. Now, first boy completed one oscillation, 360 degree. Okay, 360 degree he completed. That means 2 pi. This boy 270. He went here, came back. Clear? This boy reached up to here. This boy reached up to here. This boy 180 completed. He is just going here. 170. This is 150. This is 90. This 80. And then 50, 0. Like that. Is it clear?
Yes, sir, it's clear.
So this particle moving only up and down. But you can see this wave keep traveling like this. But individually, if you look from the top, this boy walking only along straight line to and fro between these two lines. He is walking only along straight line. But the walking is what? An orderly manner. First one is going, second one is going, third one is going. So first one when reaching here, second one is reaching like that. I will send a video. You'll get a clear idea about it, how this wave is formed.
Okay, sir.
You must watch that.
135 present.
Is it clear?
Yes, sir, it's clear.
This kind of
Yes,
wave
sir.
motion is known as transverse wave. Longitudinal wave, same thing. But think all are in a line. First boy pushing him and coming back. So second boy going forward, pushing him and coming back. So to and fro motion. same way it goes along the same line. So transverse wave is the wave in which particle making a simple harmonic motion perpendicular to the propagation of the wave. But in longitudinal wave, particle making to and fro motion, simple harmonic motion in the same direction of the wave. Is it clear?
Yes, sir.
Now you understood phase difference on the wave also. Clear?
Yes, sir.
All
It's
right.
clear.
Once we got this idea, it's very easy now. Within 2 days, we can finish the portion. Right now.
How is longitudinal waves?
Now
Less
time
than
up.
one.
Is there any possibility to do one more class? Do you have any English class? English period?
Period,
I'll ask
sir.
madam.
Sir, today
we
one
have
more
to
class
do
is there, sir.
after
Yeah,
One more class we
please.
have? Oh,
Today
okay,
one more class.
that's enough. That's enough. That's enough. Okay, then
Sir,
1 minute.
33%.
Just finish this one. Transfer